Hello guys, welcome to this section 2 of our course cluster. It will be our theoretical part of this course. I will call it Introduction to Ceph. All theoretical information you should know about Ceph storage cluster will be crystal clear by the end of this section. Okay, so let's deep dive on this part. What is Ceph? First of all, by definition, Ceph is a unified distributed storage system designed to provide an excellent performance, reliability and scalability. It's self-healing, it's self-managing and run on community hardware. This means that when a Ceph storage cluster is very well designed, we can lose one node. This Ceph storage cluster will continue to serve the IO, and request to the different customers. We can add new component like drives or OSDs. This cluster will continue to serve the request to the different customer. You can lose one node, automatically data will be redistributed to others node which remain into your cluster. This is what is Ceph. It's a unified storage, it's scalable, it's reliable. We can lose any kind of component. If you are very well designed your architecture of your Ceph cluster, you can lose a node, you can lose a disk. This cluster will be still up and running. And scalability is about to be able to add new node or new driver to your cluster, and this cluster without experiencing no downtime to your cluster. And why we call it a software defined, because it's hardware agnostic. This means that you can deploy it in a HP node, or a Dell node. It's intelligence. We have intelligence in software. This means that we don't rely on a central controller to proceed data. We have another thing, is a very flexible configuration. There is no vendor looking because it is an open source. This is a characteristic of a software defined. So let's compare Ceph storage to the traditional storage solutions. The traditional one have some characteristics which differ to the Ceph storage cluster. From the traditional storage cluster, which is there are like NetApp on EMC Avamar, for instance, are proprietary. Have a proprietary hardware that comes with the software. We have a software layer and we have a proprietary, physical host. So those things it is a vendor-looking architecture, definitely. But Ceph is not the case. You can run the software on any kind of software. You can take HP's nodes, we can take Dell nodes also, we can put them together and we'll be able to deploy your Ceph cluster and to build a very resilient cluster. You can, regarding the scale up, it's sometimes very costly when you have a proprietary vendor. But for Ceph storage cluster, it's not the case. You can take any kind of hardware, and take them and put it in your cluster in order to be able to scale up, or scale out. Where we have, when we have a backend storage cluster with a traditional server, or traditional vendor, for instance, like HP's, we can't take another vendor and say that I want to extend my cluster with another vendor. It's not possible. Everything should be done with only one vendor, for this particular storage. And we have a very high CapEx and OpEx. The capital expenditure and the operation expenditure is very high for the traditional storage systems. We have a limited flexibility. Sometimes we can provide only one type of storage, like a file or object, but it's not the case for the Ceph storage cluster. With only one storage cluster, we can provisioning the three types of storage: object, file, and block storage. There is no licenses fees for this software because it is open source, so we don't have to pay any penny for this software. It's totally open source and free of usage, and the source code also is publicly available. Okay, we can use it as a backend story for your cloud environment. You can use it also for the enterprise backup and archive if you like. You can, because for the backup and archive, for instance, you can use a RGW, for instance, of storage types, and be able to have a folder where you'll be able to store your different backups or files for your environment, definitively. So now let's deep dive in the architecture. We will see the architecture of the Ceph storage cluster, what are the different components, and in the part 2, we will see the definition of each part of this architecture. Here is the architecture overview of your Ceph storage cluster. When it comes to the architecture of Ceph storage cluster, we have mainly two parts. We have to put this one as a cluster clear. We have two parts into a Ceph storage cluster. We have the client layer part, and we have the backend storage part. Okay, we have the whole clusters, but install this cluster we have the backend storage part and the client layers. Okay, the client layer is formed of the RBD, okay, client of the RGW, CephFS, and the RADOS. Okay, natively here is the different client layer of your Ceph storage cluster. Okay, and another part is the backend storage cluster. The backend storage cluster is called RADOS cluster. Okay, this is the backend storage of your cluster. It's called RADOS, and this RADOS is formed of the different components which are Mon, Monitor, Manager, MDS, and OSD. Those components are put in together form the RADOS system, which is defined as the Reliable Autonomic Distributed Object Store. Okay, the RADOS is formed of this whole component. We have the OSD, Monitor, Manager, and MDS. All those components are the backend storage of your cluster, and the front-end storage cluster, which is the client layer part of your cluster, is the CephFS, okay, with the RGW and the RBD, because you can deploy your cluster and without activating this RGW. Okay, we can deploy your cluster also without activating the CephFS, for instance. So those layers are the client layer of your cluster. Okay, don't confuse with the external client we want to communicate with your cluster. Don't confuse with it. Okay, so into your cluster we have two layers: the client layers and the backend layers, which is the RADOS cluster. So in the upcoming part 2, I will define all single components that we have here. Okay, all single components will be defined into the next part that's coming in this slide. Okay. So the latest version of the Ceph right now in 2025 is the Ceph Squid. Okay, this version is the latest one at the moment where I'm recording this video, and this is what we will use during our lab environment. Okay, and this version introduces a new functionality, which is, for instance, the MSRR. Okay, it is a new option that permits you to reduce the number of nodes needed in case of using the pool EC or pool hierarchy coding, but I will define it later. For now, I've just announced to you the different features that comes with this latest version. We have also the live migration support. We can migrate data from a pool to another pool. Okay, definitively. This is a new feature. This comes with the Ceph Squid. We have also the NVMe optimization. So we have the improvement of the dashboard. We have a container native also improvement. Those are the different features that comes with the Squid release. Okay. And for the past release, we have the Pacific, Quincy, and Reef, and Squid. Squid is the last one. Ceph is about 20 years of innovation. Since the first release of this version, so till now, after 20 years, we have this solution is still innovated, and we have bringing new features depending on the evolution of IT environment. Okay, so this is a very amazing tool, amazing platform that we have right now, and this platform is continuously updated by the community. Okay. So now let's talk about briefly about the RADOS. As I told you already, RADOS permits to have the three types of storage. Okay, and it's organized in objects, pools, and pages. Okay, when RADOS is working, the backend storage is working with those components, objects, the pools, and pages. Those are the different components that on which the RADOS is counting on to be able to store your data and to be able to let you retrieve your data from your cluster. Okay, so all those components will be defined in the different parts of this upcoming slides. Okay, so those components permit to the RADOS to achieve those the characteristics: the replication, the consistency, the self-healing, the scrubbing, and the crash algorithm. Okay, and this in our point is the crash algorithm. This one permits us to determine where we have to store the data efficiently and evenly. Okay, the scrubbing permits us to the RADOS to check the consistency of the data and of the data integrity into your cluster. We are also the self-healing. The self-healing permits us to the RADOS to say, hey, I am losing one drive or I am losing one OSD. Okay, let's replicate the missing data on another node. Okay, this is about the self-healing without the intervention of any administrator. Okay, we have the consistency, the replication. So when you try to store one data, okay, the same copy is duplicated to another copies to have multiple copies of the same data into the cluster. So in order, if you lose one node, you still have others copy into your cluster. Here is some comments that we may encounter. We will use it during the lab environment. Okay, those comments.